human. I actually look like this. Let me take you to the social insects world, where there's no place for a central power to thrive. What is PIPORNOT? It means primus inter pares or not, first among equals, senior or representative member of a group, or not negates the former. I have no power over my workers. I guess I will be a powerless queen then. PIPORNOT is a collaborative project led by an interdisciplinary artist, Ari Coco, in collaboration with theater maker, writer Julia Bennett. It is an immersive exploration of temporary community building through insect eusociality. Communicating with scientists who study insect social evolution and behavior, the concept of community will be examined by paralleling human society with insects' non-hierarchical systems. Wait, what? What is eusociality?
My name is Annick Evans. I'm an evolutionary ecologist. So I study something called mutualism, and that is cooperation between different species. At the moment, I'm a postdoctoral researcher at Rockefeller University here in New York. The strict definition, biological definition of eusociality is that there's actually what's called reproductive division of labor, where there are some individuals that get to have children and others are sterile. Ants and bees and wasps are really good examples of that. They usually consist of colonies with one queen that gets children and then all the workers that are sterile.
Let's take a closer look at the insects colony. I'll take you to a lecture by another scientist.
Hi, my name is Pipo. I'm an evolutionary biologist by training. I currently study ants at the Rockefeller University here in New York. What is maybe the most interesting thing about social insects and ants that although they can live in societies that count hundreds or thousands or millions of individuals, the colony as a whole seems to behave and to function as a single organism. I'm going to explain this concept of the superorganism, which is a term that was coined to really convey this idea that in insect societies, the biological entity that matters is really the entire colony and not the individual. And so in an ant colony, for example, the vast majority of the individuals are workers. They have been compared somatic cells, which are, for example, the cells of your skin, of your liver, or of your brains, which are cells that really keep you alive, but that will not be passed on to your children. And queens, on the other hand, are extremely fertile. In fact, their only function is to lay eggs and to reproduce. And so in that sense, they are analogous to the cells in your body that are directly involved in reproduction and that will be passed on to the next generation. This is now a group of weaver ants that are building a nest out of leaves, and they do so by pulling and folding leaves to bring them closer together, and that will form a cavity in which they will live. They stick the leaves together using the silk that is spun by the larvae in the colony, and that is what that whole weaver is.
I'm an entomologist and a chemical ecologist. I study social communications in termites and ants. A superorganism is a social unit of animals, and these animals are the same species. They are closely related to each other, and they have distinct division of labor, and they work highly cooperatively, and they cannot survive by themselves. Termite is a very good example of a superorganism. They have a division of labor between castes. They have reproductive castes, the queen and the king. They have workers and soldiers. The king mates with the queen, and the queen lays eggs, and all the other individuals are sterile. They cannot reproduce. And the workers, they do most of the jobs in the colony. The whole colony functions as a cohesive unit.
Ants have what we call division of labor, which means that the work is divided into tasks, and that all those tasks are performed simultaneously but by groups of specialized workers. And this picture is of the species I actually studied in the lab, as well as many colleagues, and it's called the clonal breeder ant. And so once the ants are painted, we simply throw them into colonies. Those colonies are just very simply plastic boxes with a plaster floor, and we let them organize themselves. We give them larvae, so they will usually start building a nest in one area of the colony. We use webcams to take pictures of them over usually a month. This this is what the data looks like, really, in one of those colonies. This is a group of, I think, 12 ants, and they have larvae, and what you can see is that they will organize the larvae into a tight cluster in one part of the nest. And then at any given point, some ants will be in the nest taking care of the larvae, and others will be running around. You can also see that they start building a small trash pile at the other end of the box. What you see emerge in almost all colonies is a form of emergent division of labor. And so what you can see here is that young workers stay in the nest, pretty much. They spend a lot of time in this, in the part of the square corresponding to this area, while the older workers spend a lot of time just running around the colony, and this suggests that young ants are really the ones that become nurses, and the old ants are the ones becoming foragers.
Sounds like it's about time we look into division of labor. So as you can see, I don't really rule the colony as a queen. I have many worker ants working hard for me and helping the colony to survive. I'm usually chill, but don't assume that I'm just messing around. I've got some work to do.
Reproduce.
Now let's go see some real ants.
Get some ants. So here you see official museum portraits of ants. So every ant has been glued to a piece of paper. It's called Lasius umbratus, and then this is Lasius flavis. It's smaller, Lasius nearcticus, and this is the way we archive ants. This is the official way that is used in museums. Ants are cold-blooded, so I put a warm lamp on top of them. They get active, and now they warmed up because I put a lamp on them, and now they start bringing all their larvae to this other place. I never get tired from looking at ants. The ants that I just showed you are Lasius claviger, that you recognize these relatively big eyes. They're yellow. Yeah, these ants only live below ground, so I basically can only find them by digging around. And the easiest way to access them is flip rocks in the forest. So I take a rock and flip it, and in the time I've been in New York, I must have flipped close to 1,000 rocks, and under 370 of those I found an ant nest.
The success of a superorganism is largely dependent on biological altruism. To explain the altruistic nature of ants, two different theories should be brought up: group selection and king selection. Would you share your opinions on this subject, or are any elements of those theories factored into your own work?
So yeah, I believe that at this point, kin selection. Well, basically, when you boil it down to the mathematics, they pretty much say the same thing, and I believe that kin selection has the most intuitive explanation for altruistic behavior or cooperation within a species. It really says that it's called kin selection, but it's also called indirect fitness, where you as an individual can profit from altruistic behavior because your kin will actually share the same genes as you. So even though you lose energy or maybe even the chance to get children of your own, helping the others will be good for you in the long run because your genes are still going to be passed on to the next generation. That's a really interesting notion that actually Darwin already thought a little bit about, but it has only been worked out over the last couple of decades or this century, last century. And it's interesting for my work actually because it fuels the question that I study, because I don't study cooperation within a species like ants do. I study cooperation between different species. And by definition, it cannot be explained by indirect fitness or by kin selection because organisms of two different species will never share genes. They only have their own genes. So that's actually the reason why mutualism or cooperation between different species is such a big mystery, because we cannot explain it by kin selection or even group selection. So yeah, it fuels my work and it makes me wonder why, how could this evolve if we cannot explain it by kin selection.
Finally, help me carry my ship wings.